Draw a segment from the center to a side. What is that called? The radius. Okay. Radii, what do you know about all the different radii within a circle?
They're all equal.
They're all the same. The radii of a circle is what defines a circle. Remember, circle is a set of points that are all equidistant from a center spot. Well, the radii connects the center to the edge of the circle all the way around. That's why they're all congruent. After that, we did something called a chord. A chord is what? Oops. Goes from one side to the other, but more importantly, it stops on the circle. It has endpoints on the circle because it can go through the circle, and that was something different. Okay? So when you go and you have endpoints on a circle, you are a chord. Speaking of, the most famous chord of them all, the one that goes through the middle, is called the diameter. The diameter is made up of how many radii? Two of them. They are, bless you, if you want to think of it as a radii is, they're opposite rays, but the rays have endpoints, so they're opposite segments. Yes? The diameter is a chord because it has endpoints on the circle. It's the most important one because it cuts the circle into what?
Equal halves.
Equal halves. So if to get around a circle is 360 degrees, to get around halfway is 180. Very good. That'll come into play a lot more starting tomorrow. So you've got your diameter, which cuts it into what are two semicircles, which I'm sure you guys have all heard. It's a chord. Is the other part of the diameter is that it will always be the longest segment that you can draw within a circle. Okay? Excuse me. When you go through a circle, a line that goes through the circle is called the secant. It's the secant. Oh, just wait a second. Oh. So the secant is the one that goes through the circle. All right. Can a secant go through the circle as a diameter? Yeah, it doesn't matter. The secant is just going to be your line that goes through the circle at 2 points. Now, what happens when a line touches the circle at 1 point?
Tangent.
It's tangent, very good. And when you touch the circle, come on, guys. When you touch the circle at exactly one spot, you are called tangent. When you are tangent to a circle, you do something to said radius. Any radius. You're perpendicular to it. Very good. You are always perpendicular to the radius of a circle if you are tangent. Now, one thing that we forgot to mention yesterday, the point where a tangent spot hits a circle is called the point of tangency. I just forgot to throw that in there. The point where the radius hits the tangent, where it's perpendicular, is called the point of tangency. Oh, I just want to add that. What?
How would you label the tangent?
What do you mean? How do you write that?
No, like in the directions, how would it say like tangent?
Oh, it would say line JH is tangent to radius AI at point I. It would be something quite literally that specific. All right. Or in a diagram, you'll just see the right angle and know that it's tangent. All right. There it goes from there. I think that's basically all of them on that diagram, because I think the only one we forgot to define them would be the common tangents are, and that's where we left off.
Yeah.
So we get to what are called common tangents. Good. It's the same thing we drew yesterday, guys. Should be in your notes. Common tangents. It was also the homework from last night as well. So common tangents. Common tangents are when you have a tangent that's tangent to two or more circles. For example, if you have two circles that are overlapping, they would have two common tangents. Okay? If two circles overlap at some point like that, they could have two common tangents because these are what we call common external tangents. Those tangent segments are always on the outside of the circles. They never go through the circle. The minute they go through a circle, they become secants. We don't want that. When the circles are apart from one another, you still get those two on the outside. Oops. But you also get two more that can go between them. So if the circles are pulled apart from one another, there is a possibility that you could have 4 tangents. And if the circles, if you look at that last one, the circles themselves are touching at one spot, which means there's only going to be one spot that I can be tangent to both of them. I believe one of the questions that we had from last night was, we had the first two, if I'm not mistaken, but the other one of the diagrams looked like this. How many tangents can you draw if they look like that? 0, very good. Because those two circles aren't going to touch each other anyway, so you can't draw a line that just touches them both as it is. Because you can't go through a circle because it becomes a secant. Right. We normally don't worry about what would be called common secants or worry about having multiple ones of those, but depending upon where we get, I don't think we're going to see it until after conferences, really. Sucks this unit's all broken up. But we go from there. So that's kind of what you were doing last night. Nothing crazy, nothing too nutty about any of it. It was pretty straightforward. What we do then today is we build off of that, knowing that when we worked with the that angle bisector yesterday, how that if you were on an angle bisector, you were equidistant and perpendicular to the sides, which because of hypotenuse lay gave you this, which meant that you could do this, and I think this is kind of where we left off. That's where we left off, right? All right. So what happens here is that you can get what are called external tangents. Any point that's on the outside of a circle and it touches the circle at one spot will always create some sort of right triangle within the circle. Here's what I mean by that. So we did this one. If I take a circle and I draw a radius and a point of tangency, that has to be 90 degrees, doesn't it? Because at any point that, or any segment or line or whatever that you draw to a circle that touches the circle at one spot always creates a right angle at that circle to a radius. So what we're going to be able to do is we're going to be able to use a whole bunch of Pythagorean theorem to solve for bits and pieces in this. This is absolutely nothing new from things that you've done in the past because this is just Pythagorean theorem problems that you've seen where this is your hypotenuse, so here's your c squared, a squared, and a b squared. The only thing that winds up being different is that there's a circle in the picture. That's it. Okay? So none of the math stuff that we do today is going to be anything different than what we started back in the middle of January when we came back from Christmas, as we started second semester. And you guys have also remembered we did a whole bunch of Pythagorean theorem during first semester as well. So Pythagorean theorem doesn't go away. It keeps rounding around the corner and showing up. Anyway, so we can do something like this. Okay, we can do something like this. Don't get scrunchy face. It's just Pythagorean theorem. You know how to do that. So what are you solving for here? X. In this case here, the segment of X is playing the role of a what of the circle? A radius. Yeah, it's the radius. So what we can do then is just go to old. Which one's the hypotenuse? The 96 or the 100? The 100. So it's just nothing more than x squared plus 96 squared, bless you, is 100, bless you, squared. By now, you should be able to throw that directly into the calculator as 100 squared, subtract 96 squared, hit enter, and then take the square root of it.
Yeah.
You should get 28 then. Right? So, like I said, this doesn't change anything that you've seen before in the past. You're still doing the exact same math that you have before. The only difference is that there's a circle involved. But if you don't pay attention to the circle, you still have Pythagorean theorem. Right? You buying it, Chope?
I don't know how long I'm going to find it.
We hope. Okay. So let's review some things. Also, some things that decide to rear its ugly head. Besides Murphy, you get stuff foiling, distributing, junk squared, and factoring. This section, or this chapter I should say, is one of those that continually redoes everything that you have seen. Okay? So if you have the two binomials, x plus 4, x minus 6, and you have to multiply that out, you just FOIL it. First, outside, inside, last. And write down what you're doing. Don't try and do it in your head. Okay? I'm asking a lot, I know. And this is, again, something that each and every single one of you guys have done before. We did it a bunch this year so far, and I know you did a ton of it last year. So when you multiply that out, you get the x squared minus 6x plus 4x minus 24. Combine your like terms, and you're left with x squared minus 2x minus 24. And that's what it looks like factored or FOILed out. Excuse me. All right. The next one, x plus 5 quantity squared. What do? What's that?
Oh, you double it and
Yeah.
you have to write it out.
You have to write this out, guys. When you have junk squared, anytime you have a binomial that's squared, that means junk times junk. You can't distribute the exponent. If you do that, a puppy dies. I'm serious. This means junk squared. Junk squared stands for junk times junk. It's the dumbest thing in the world, but I guarantee 4 or 5 of you will screw this up every single time. Please stop killing puppies. They did nothing to you except give you their undevoted love and admiration and loyalty and slobberies.
They do it out of love.
So you would FOIL that out. Now, granted, there are shortcuts to FOILing out junk squared. If you know them, great. If you don't, it's okay. Because you can always write down junk times junk and FOIL it out. And you wind up with x squared, 10x, and a 25. The same exact things that you guys have seen in the past. What? There's no such thing as a dumb question.
Really? Because he said he asked about 10-hour lunch. It's 10 hour right now.
That's a dumb question. I try to stick up for you. I know. I can't. Dude.
I was like,
Okay.
no.
Now remember, just remember this, guys. Junk squared, whether it's x minus 5 or x plus 5, anything squared, multiply it out twice. You have to. Think of the puppies. Or I'm going to play Sarah McLachlan over and over until you... There's a commercial that shows puppies in cages dying.
No.
You know what song we're talking about now, right?
No.
Yes, sir. First, outside, inside, last. So you multiply your first terms, your outside terms, inside terms, and last terms. What, Billy Binomial?
It was like some teachers showed us like these puppies dying and everything, like for speech.
Yeah, he showed us that commercial.
Everyone was dying in that class.
It's awful.
It was awful.
Factoring. Factoring is also a skill that does not go away. In fact, it's something that we utilize a ton of in this chapter. Also, just a quick reminder, I know that there are so many different ways to approach factoring. I like to kind of go back to the way that no matter what, it will always work. A lot of the new algorithmic ways that people are showing, or that they're showing students how to factor and how to work with those, that's great. But as you get to anything upper level, it becomes very, very difficult if you don't understand where it originated from. And that's the method that I use, and that's the what are the factors of positive 40, what times what's 40, that you add together to get the negative 15. I always fall back to the old-fashioned. Did I say 15? Sorry, I meant 15. Thank you.
You meant 13.
What times what multiplies to 40. So think of your factors of 40. You've got 1 times 40, 2 times 20, 3 doesn't work, 4 and 10, 5 and 8. And then all of a sudden you're at 6 and 7, those don't do anything, and then you're going back on down the road. So of those combinations, you have to also think about the signs. Two numbers that multiply together to get positive meant they both have to have the same sign. They're either both positive or they're both negative. Well, when you add two numbers together that are positive, you always get a positive result. If you add two numbers together that are negative, you always get a negative result. So that means it's going to be -5 and -8. Which creates your, what we call, terms. Terms are your factored parts. Terms are always what goes in parentheses. The x minus 5 is a term, the x minus 8 is a term. What we do with terms is then we find what are called zeros. What's that? We find what are called zeros. And that's when you set those equal to 0. And if you remember, this was a pretty easy thing then. It was the x minus 5 is 0, and the x minus 8 is 0. You're figuring out what makes one side 0, what makes the other side 0. So if x is 5, or if x is 8. And if you really, really, really get into it, what you were really doing you were figuring out where the parabola crossed the x-axis. Because an x squared function is what we call a quadratic, a parabola. that all of you guys did last year. You found zeros of a parabola where they cross the x-axis. You were able to graph them. The first term was positive, which means it was up like a cup. If it was negative, it would have been down like a frown. Okay? Things like that. So in essence, this is kind of the root of all, not root, that's a root. This is kind of the basis of all algebra. Actually, it is the fundamental theorem of algebra, which you do all again next year in Algebra 2. It's a squared term, which means you have two possible zeros. That's all that means. And you have it. So why do we show you guys this? Because you're going to see problems like this. Yeah, this one. We have a tangent segment to a circle, and we need to solve for r in this case, well, excuse me, x, where the x is the radius of the circle. Again, do you really need to draw it with a circle?
Yes.
No. Could you draw it as a right triangle? Why do I have two x's? Because one of the values of x is this segment. The other value of x is this segment.
Oh, but they're gonna be.
Because they're radii, correct. Which means, what's this entire segment then? Am I multiplying? There you go. The whole thing would be 49 plus x. All right. So is it okay if I say x plus 49 though? Doesn't matter if you go the other way. What's going to happen here is that this entire segment then becomes x plus 49. Because all it is segment addition. You're adding two chunks together. You've done this exact same problem before, just without a circle in it. You've done this before. The only thing that changes is that they put a circle in it. Okay? So writing it out, what of those three segments is your hypotenuse? The x plus 49, because it's opposite the 90. So that just means in order to solve this out, I'm going to use that Pythagorean theorem again. So I'm going to get an x squared plus a 63 squared is the quantity x plus 49 squared. And that's the reason why I was reminding you guys about that whole junk squared portion. You'd have to FOIL it out. Yes, ma'am?
So then one of the x's you just put as x squared instead?
Yeah. Yep. Because it's just the side length of a right triangle.
Okay.
That's all it is. A squared, b squared, c squared. That's it. Okay? And since that value of x is going to be the same number on both spots, you're just adding it to the other one. That's all. Okay? So now you just start using your calculator to figure out your 63 squared. Well, x squared ends in a 9. It's 3969?
Yeah.
Okay. And then over here, this is the same thing as saying x plus 49 and x plus 49. Well, as you FOIL that whole thing out, you're going to get x squared, 98x, 2401. Are you guys shaking your head about where I got 98x? Okay. 98x I got from, if I go first, I get x squared. The outside is 49x, and then I do the inside is 49x. 49 and 49, if I put them together, I get 98. I was just shortcutting it. That's all. So if I FOIL out this whole thing, I'm going to get x squared by doing all that. I just did 49 plus 49 in my head. That's all. Okay? So now you have variables on both sides of the equation. What happens to the x squareds? How? They cancel each other out, exactly. See how they both have the same exact coefficient? They both have a coefficient of 1. 1x squared on the left, 1x squared on the right. If I subtract from the right to the left, it becomes 0. If I went from left to right, it also becomes 0. So this is one of the things that's going to happen quite often with these, is that this x squared term probably drops out, especially if they're on both sides of the equation. And then you're left with a very simple two-step equation. And then we just divide it out. I believe it's 16. There you go. Okay. It's not that the math portion of this stuff becomes horribly difficult. It's the idea that you have to remember things from previous things. That made no sense. You have to remember things from previous classes. You have to remember how to do algebra. Just like you have to remember how to multiply, you have to remember how to add, subtract, all that other stuff. Just that it kind of expected as you do that in math. This is what we do. That's how we are. So, do that one real quick. Here, so let me fly through this. You get r squared of 15 squared, then r plus 9 quantity squared. Are we okay with that? Foil everything out. We're going to get r squared, a 225, is r squared 18r, and an 81. R plus 9, foil out, you get 18r in the middle. What happens to the r squareds? They go away, just like I wish you would. I tried.
Then you see
So-
me at the end of the day.
I know.
Say, hi, Murphy. You're like, going in.
I know. And then I subtract the 81, I get a $1.44.
No, then you walk out the door.
Yeah, that's true. Divide that out, and I believe you get
8.
8.
Yes. You're welcome.
All right. Now, do real quick here, throw it. On the sheet that I just gave you, do the back side. Starts at 21. I think it's 21 through what, 33?
Yep.
It's very, very, very quick. Just add that to the problems you did yesterday. If you look at the front of this, that mirrors the problems you did yesterday out of the book. So today, just write these problems down on that sheet of paper you started yesterday, and we'll collect it all tomorrow. Okay? All right. Do it on the other sheet that you already have going. That way you have room to do all your algebra. Which one do you think is the back? Or how about this? If one of them starts at number 1.
So you do the entire backside?
Yes. Again,
Are you sure?
I would make sure I would do numbers 21. Is it 33?
Yep.
All right. Do those. Thank you.